Cool, thanks for making it through the maze. I'm going to move pretty quickly, but because the talk's on cross-platform, I thought I'd make my slides in HTML5 as well. So everything's online. You could even look at it during the talk. I'll give you the URL afterwards. And so don't worry if info goes fast. You'll be able to catch up. So just real quick about why I'm talking about this. So we have a studio called Double Coconut. We consider ourselves a boutique studio. We're small. We work on select projects for various clients. And more and more our clients seem to really want cross-platform games. So either they want HTML5 games that run literally in the browser, any browser, mobile browser, tablet browsers. Or a lot of times they have an iOS game that's doing well and they want to expand that to Android, and then they want to expand it perhaps to Facebook. So we've done that type of work as well. And then a lot of times as well, we look at a game, and either when we're creating a game from scratch or porting a game over, it's easier to do it as one code base, which then becomes maintainable across all platforms. So that's another typical need. So we've done a lot of that, and when you talk about cross-platform, it's pretty jaggedy. Obviously, we want to be on iOS and Android, maybe other phones, maybe the Windows phones, maybe the BlackBerry. Obviously, different form factors, tablets, handhelds, mini, tablet mini size, and new sizes of phones to come. All makes it really interesting. The different app stores, and then the second-tier app stores, and a lot of times publishers will even want their games on PC, Mac, and even consoles, current generation and next generation consoles. So it's there's a lot you can do. Now, as far as what you want to do and what you ought to do, there's actually like I think three reasons, or at least that we found, that people want to go cross-platform. So the main one, or big one, is for player continuity. So it's kind of an engagement play where the players are enjoying the game on one device. A lot of players, they've done research on their players and on the audience has multiple devices. So they want to be able to pick up, play at work, during their lunch break, of course, and then come home and play and continue on their tablet. The second reason people want to go cross-platform, really popular, of course, is just more money. Right? More stores means more people, more players, more money. And then the third reason is because people really believe in the browser as the place that they want to publish their games. So that's where the browser frameworks come into play. So why go cross-platform, right? You look at some of the most successful quote-unquote cross-platform games like Candy Crush, and it actually doesn't have. Well, I shouldn't say why go cross-platform. Obviously, a lot of the reason for the success is because they went cross-platform. But why use a framework, right? Like Candy Crush did really, really well, making just really, really polished iOS version, really, really polished Android version, and really, really polished Flash Facebook version. Of course, they had a lot of testing, a lot of process. But all that amounts to a lot of time. And depending on the size of your company and the taste of your company, you can't really spend as much time perhaps as King spends on their games to go cross-platform in a unique, tailored way. So the good news is there are some amazing platforms out there. And a lot of the platforms, if you really do your research and talk to developers, there's some actual happy developers out there. There's also a lot of really sad and pissed off developers out there. So what I'm going to try to do is go through as many of these platforms that are relevant as possible, and hopefully give you guys some idea of, if you're making a game, or if you were kind of debating to use one of these frameworks, which ones might be right for you. So let's quickly talk about the different ways that you can get cross-platform, because there's a bunch of different ways. I could start showing you diagrams like this, but it'd be more boring than it already is. So I borrowed my daughter's toys, and I'm putting together hopefully a little bit more interesting view of how the different platforms work, or the frameworks work. So native code, or native games, I think we're all kind of aware of that. You build the game in the native language, typically Objective-C for iOS, typically Java for Android, etc. You make a really tailored version of the game, and you output it to the device. On the other side, on the HTML side, there's pure web, and that's typically, when we say pure web, we mean HTML and HTML5. And that's really, it's a web application. It's really just a very fancy web page. Sometimes you can't really tell the difference between that and a native app, but if you look closely, what's happening behind the scenes is it's just HTML and CSS and a few other technologies working together, playing on browsers across various devices. Then there's the hybrid approach, and this is where you write something in HTML, typically in JavaScript, And but you're rather than having it run in browsers, you're having it run in essentially a specialized browser, which which doesn't just render the code, but does stuff like cameras and location and graphics and sound and all the special features of each device. So technologies like Cocoon.js and PhoneGap are this hybrid approach. Then you have your interpreted way of doing cross-platform. Very similar to what we just showed to the hybrid, but rather than the language being JavaScript, it might be any language. It might be Java, it might be Lua, it might be some other sort of scripting language, which then runs on an interpreter. And the difference is literally these treadmills represent little machines, little runtimes, and what they're doing is they're looking at the script of your language and interpreting it on the fly on each device, and it doesn't necessarily have to be slow when it does this. And then finally, the most kind of typical framework architecture we're going to cover is compiled. And what that means is you have one code base. Sometimes it's a little fractured, so that's why we have that little crack in the middle. But you have one code base, could be written in any language essentially, and that language gets, and then that code base gets added and kind of complemented by platform-specific code. So little bits of code for iOS, little bits of code for PC, little bits of code for Android, and then gets cranked through a compiler, generated into a final binary that runs. So it's an interesting way, and probably the most typical way that most of these cross-platform frameworks work. All right, so that behind us, let's do a little bit of a deeper dive into the actual frameworks. So there's a lot of them. I mean, this is just a partial list. There's tons and tons of them. It's a very popular play. It's a really, really exciting thing to do because the promise is great, right? If you can achieve it, write once, run anywhere, that's unlocking the world. But just so we can kind of narrow in on the stuff that I believe is most relevant to you, an audience of casual game developers, one would presume. Let's talk about frameworks that really work well for 2D sort of casual games that have been used successfully for top games, specifically on iOS and Android, but obviously there's a bonus if it works on PC, Facebook as well. And also that are kind of proven and have proven technology in a proven community. So the first framework is Corona. And for each of these frameworks, I'm going to give you a little bit of the pluses, a little bit of the minuses, and then at the bottom there's the price and some major games that it was used for. And pay special attention to that last point because I think if it was used in a game that's done well, that's a really good endorsement of the framework. So Corona is one of those interpreted solutions. You're using Lua scripting to create. What we don't like about it is it's very slow to build. So it works actually really, really well. It has some great frameworks and great libraries and most of the main stuff you'll need. But if you want to start customizing it, you're going to run into trouble. And it's pretty slow to crank out builds on different devices. So if you have the type of cycle where you're making tweaks and pounding out builds to device, it's going to be a little bit problematic. Then there's Marmalade. Marmalade, as you can see in the bottom, has been used for a lot of successful games. It's typically C++, so the reason a lot of people use Marmalade is because they're PC developers. They have PCs, it's a PC shop. They don't want to have to buy Macs just to run, just to create Objective-C code. And it's a great framework. Really, really deploys quickly across different platforms. Does have some issues, because it is proprietary. It does have, when there are bugs, you sometimes cannot find them. It's in Marmalade's code, but for the most part, there's been good results. Xamarin is an interesting framework. So that one is built on C#. So if you are a Xbox house or your developers prefer C# because they're Windows or XNA developers, it's a great way to get your XNA code onto mobile platforms and also Mac as well. So it's pretty cool, but there have not been a lot of successful games yet built in that, but might be worth checking out if you're a C# sort of guy or gal. Then there's libgdx. So libgdx is liked by a lot of the indie community because it's completely free, completely open source. You can go in there, you can tinker with it. If things aren't working well, you can figure out why. Typically, the writing is in Java, using Eclipse or IntelliJ as your development environment. And it's pretty cool. You have one code base, and you write your code and you write your game, you write your physics, you write your sprites, and spits it out pretty well to Android, BlackBerry, and Windows almost effortlessly. And then there's a project on top of libgdx called RoboVM, which pumps it out to iOS. And iOS does take a little more time, a little more effort than the other platforms, but it does work. Great community, very supportive. Still kind of early days, not a lot of successful games yet built on this framework, but definitely worth checking out if you're a true engineer and like to go in and tinker. Then there's Adobe AIR. Adobe AIR was popular for a while when people were talking about taking their Facebook sort of flash games and moving it to mobile. There'd been a lot of experiments. We experimented a lot. The big negative is the reason you'd want to use Adobe AIR is because you have a flash game that you want to port over. However, if your flash game uses vectors, which a lot of them do, it runs incredibly slowly on devices. So, but that said, if you love Flash, if you love ActionScript, Adobe AIR might be worth checking out. But if you really like ActionScript, there's also a open source project called Hacks. And so Hacks is basically uses ActionScript, so you can write the same way you would write Flash. You can use Flash Builder or other Flash tools. And with the Flash API and using a game framework called Hacks Flixel, you can create Hacks code and pump it out. And there've been some pretty successful games built using this approach. I especially like Hacks for prototyping. It's a really quick way to just get things built. If you like Flash, you can create your GUI in Flash and see things very quickly on various devices. So another framework is called GameMaker, and a lot of indies, especially indies doing more platform action sort of games, use GameMaker. It actually started as a tool for non-engineers, kind of a drag and drop tool with a little bit of logic and scripting on it. But it's gotten really, really advanced and really mature, and it pumps out builds that work fairly well on all the different devices. The big negative is it's completely, you're playing in GameMaker's world, it's their tools, their scripting language, and it's not very extensible. But we're checking out, especially if you, again, just want to prototype and tinker, and then maybe that will become a game. So I know I'm going through a lot of these. Again, these slides are going to be online, and we're going to do a little summation at the end as well, so hang in there. So Cocos 2DX is built upon the popular Cocos 2D platform. So Cocos 2D is probably the most popular game framework for iOS, and this is a C++ implementation of it. And so what that means is it works very, very well on Android as well as iOS. And for a true game developer, it's got a lot of the tough stuff taken care of, which is awesome. So sprites and the GUI and sound and the physics, it's all best of breed. It's all very well thought out and very mature. It is also a great community. You can find a lot of sample code, a lot of sample games out there. There's also a tool called Cocos Builder, which helps you kind of visualize your sprites and visualize your UI. On the negative side with Cocos 2D, it's it's a little complex if you're not a true engineer and like to get in and code, and the compile time is pretty slow, especially for iOS. So it works well and it gets your game to iOS, but to actually make a change and then see it built takes a while. That said, again, I encourage you to look at the list of games that have been built using Cocos 2DX, and it's quite large. Also worth mentioning, kind of riding on top of Coco's Coattails, is a Portable. So Portable is a commercial company that really has helped out a lot the Cocos community, and what they really do well and have focused on is if you write a game in Cocos 2D, not Cocos 2DX, but Cocos 2D, the Objective-C version of Cocos, and soon the Swift version of Cocos. If you write a game in that for iOS, they do a really good job of having that pump out to Android. So it actually works like magic. We've run a few examples, pretty cool. And they've also taken a Cocos Builder and kind of evolved that into a more commercial tool called Sprite Builder. So again, worth checking out if this type of thing is interest. Okay, we're getting to the end here, and can't talk about cross-platform without talking about Unity. So Unity has really become especially for 3D games, the standard. It's just a wonderfully mature, real tool. It's really grown up tons in the, I don't know, if 6 years it's been around, or more, maybe 8 years it's been around. And it's also in the last few years really gotten growing support for 2D games. So very similar to Coco's 2D as far as just the way it thinks about sprites. So you can make, it is not overkill to use Unity for 2D games anymore. Really thinks about the art pipeline and how to use assets and how to involve artists into the game. It's got built-in networking and multiplayer support. So if you're writing a multiplayer game, you might get that almost for free out of the box. And the thing a lot of people like, once you get used to the development environment, it is a different development environment than a lot of others, but once you get used to the development environment, you make changes to your assets, you make changes to your code, and you actually can see it run in the game immediately, because it interprets it right there in front of you. And I mean, you don't have to even compile. It just literally, the game will pop and the asset will show up in the game that you're playing. Very cool, very efficient. So a lot of games have been built using Unity. Price is sometimes a negative factor for some people. Also worth mentioning, if you are going down the 3D route and aiming for that model, the CryEngine and the Unreal Engine are both gunning hard for the mobile space as well. Have not had a lot of personal experience with these engines, but they look cool, so definitely worth checking out. All right, phew. So we're done with the whole survey of frameworks. Now I'm going to just tell you a little bit of real world, advice. Tips, tricks, problems we've had with just doing cross-platform in general. So the number one thing to think about is you really can't avoid some native. Especially if you're doing game as a service where the game's evolving and you're changing things constantly, it's almost impossible to not swap out SDKs and not swap out different analytics providers and ad providers and attribution providers. And you'll want to make platform-specific optimizations, and your game will load a little too slowly on this specific Android phone, and you're going to want to go in and fix that, and your game will crash on this specific PC, and you're going to want to go in and fix that. So you need to really roll up your sleeves and do native. So a solution that does not allow that may be a problem. Controversial statement number 2. Just because it works, and just because the sample code that the framework provider gives you works, is definitely not enough. The sample code, of course, works because they built it and they're showing it to you. But as I mentioned before, the biggest problem with a lot of these cross-platform frameworks is the time it takes to actually sit there and make a change in your code, and then you sit there and compile, which is usually pretty quick, build and deploy and launch, and finally get it running on a device that you're trying to test on. Sometimes that could take like half an hour, right, for a very simple change. And if you're just trying to polish a game and tweak some pixels and get something looking good, you're eating a day doing something really easy and stupid, and that happens a lot. So be very careful. And my advice here is when you're considering any sort of tool, most of the tools have free. In fact, I think every tool on the list has a free version that you can try. Definitely build a benchmark. I mean, take the time to build a benchmark. It's going to be a big mistake to not do that. And you want to build a benchmark that has sort of the graphical intensity of your game. Try it out on as many key devices as you can. Try it out on tablets, try it out on iOS and Android and PC or wherever your thing is. And if either your artists or developers are not happy, say no. Well, they're never happy, but I mean, if they're truly not happy, say no. Number 3, artists are people too. So I've been talking a lot about code-centric stuff, about a lot of the technology and programmer kind of day-to-day workflow, but make sure the artists are happy with their workflow, especially UI, right? So a lot of times UI is not really thought of as something that's malleable and changeable, but it really is. The UI from the first iteration to that A/B test 6 months in, it goes through a lot of changes, so make sure that's easy to do. So, if you're going to use these magic bullet of cross-platform frameworks, just really think through, tread carefully, do your pre-production, and once you do launch, really think through process. And that's actually true whether you're using a framework or not, but anytime you're using cross-platform, when you have potentially one version of a game running on one device and one version of a game running on another device, especially if there's a back-end component, you have to make sure they're synced up, and that takes a lot of thought and process and time and discipline and all those boring things, but you're going to appreciate it in the end. So, you know, all in all, there is no such thing as a magic bullet. None of these frameworks really just work the way native code works, the same speed, the same level of optimization, the same ability to go in and tweak and get that polish as writing native code works. But there's still some amazing magic out there, worth trying, and you know, depending on, again, what you're trying to achieve, it's definitely out there and only getting better. So thank you so much, and hopefully I left 30 seconds for questions. Oh, so on the Casual Connect site, it should be. I'm not sure when they put it up, but you could also email me, and if for some reason it's not there, and I'll shoot you a link. Hey. Oh, sorry. Cool.
Hi, I'm wondering if you have experience with the various frameworks and how they handle when major changes happen, like a switch from iOS 6 to 7 or something like that. You might have a product out there, and now you have to recompile, or there's a change to an SDK for the ad serving or something along those lines.
Yeah, I mean, in a way, that's for a framework with a good community or a very vibrant company behind it. That's one of the big advantages of using a framework, is you don't have to think about that stuff. So they've got the seed of iOS 8 well before you do, or they've got 10 developers focused on tweaking that sprite library or that sound library to work great. And in theory, you just install the new SDK and it works. And sometimes it literally is that easy. So that, in theory, is the plus. The minus is if support starts waning, you're stuck. You've built your code on somebody else's platform, and so pick your partners well, like anything else, right?